Uh, so this is going to be a little overview of how I did the uh, data generation for the 3D point cloud for homework 7. Um, I did run into a couple issues. So in the other video where I was taking the data, I tried to create an automated system using my Pi and a servo. The automated system, as uh, explained in the other video, had a little technical difficulty, um, and I wasn't able to use the servo properly. Um, I was looking at that today, but there were some other technical difficulties, and the pictures that I was taking did not save, except for the first one or the last one. So I really only had one picture. For my target, though, it is pretty much pretty similar to the rest of them, except for maybe one side. So I wanted to kind of show how I actually was able to rotate and translate all the images, or technically sides and stuff, and how I could manipulate the data in order to get it into a 3D point cloud. So I will be going back and taking data and making sure that I'm actually getting it saved and everything. I'm going to recheck why my script didn't save it properly, but I will upload a script with, or a file with all the correct data points. So after I got that out of the way, let me explain how I did this, at least with the one side that I did have. Um, so basically started all off, we imported a bunch of statements there, and then I initialized some variables. I added this filter y when I was filtering the one side that I had, and then I have my values that I use in the LiDAR equation, and these are some other constants that I use to calculate the distances based off the image. As explained in the other previous video, I used the color picker 2 to find the correct HSV values, and in this version I also cropped the image to get rid of a bunch of noise. So right here is where I ended up cropping a lot of stuff. So my object had a thinner part at the top, so I said if the angles were less than 20, so 20 to 0, it would crop it, and if it was anything else, it would be a little less cropped, so I could get the full range. Here's the amount I blurred the image, and then it went through the HSV. Then here, I did a variable a variable filter for the HSVs. This is something that I talked about in the previous version in order to get out a lot of noise, and I was able to get out a bunch of noise. It was pretty clean data after that. And then I ended up, so basically there I get these values for all these various angle values, and then I input them here. And then down here, it basically is looking for any values in each row. So if the vertical line that you saw in the picture had a white spot, it would basically record that, and then it would average it, get all this stuff, and then it would basically then calculate the distance that it was away, and then it turns from Cartesian, or sorry, from polar to Cartesian, and then it inputs it into a string and then writes it to a file. So the file that I was writing to was called file name, which I defined up here earlier. This exists thing is to make sure that if it exists, it won't rerun everything. So it'll just continue on and go down to this statement, which is basically just reading the file that already exists and putting it into lists that are float variables, and then I can manipulate that list however I want without rereading all the image files from that location. Here is something that I also added, filter Y. So basically when I took the image, I said it was in the y direction, and I had some data points that were really close. I can actually run that here. Let me run clear, or sorry, test results. So if I run this, I should be getting, yeah, so time required 0. It's still plotting. I think I have it plotting. Yeah, okay. So it read in all the files. This was the very initial version. As you can see, there's a bunch of noise over here. Didn't really need that. A lot of noise, not very good. Then I started to try to clear the noise. So if I do clean noise 1, this was the first version I had of trying to clean the noise. So if I run that, it'll pull from this text file and then plot the data. There's a lot less data in this one, so it plots a little faster. So as you can see here, here's a front view. I don't have a lot because I didn't do the HSV, but you can tell that there's a lot less noise. There's still some out there and some in close right here. So the filter Y basically gets rid of this stuff and this stuff, which is what I was going for, to clean data at least. And then basically all that data, it would go through and it would pull out all the bad values and then delete them from the list. And then down here, this is where I had to rotate and translate the data. For my case, it was just that one file, so I made that one file, and I wanted to show that I knew how to do it, so I did it in 4 different rotations, as well as 4 different multiple translations in the Y direction and X direction. And I saved them as a file with the new file name, and here is where I rewrote them to a new file. So then I was able to combine them all in the end on a separate script. And down here is the plotting, and I did 4 different plots so I could just get 4 different angles right away, so I didn't have to wait for anything. Yeah, so I will run the full script after I've put everything together. So I named this one full file. And this is basically, it's close to what I had. It's close to what the actual target looks like. Sorry, that's the old one. So this is what similar to what the actual target looks like in terms of shape. So it is like a rectangle. The problem is it should be slightly straighter. I had some issues with that, so I'm going to go and rescan again and try to recalibrate my sensor as well. But this is a top view. This is a front view. Or sorry, this is a side view, and this is a front view. But yeah, you can see that I was able to show that I had a slightly bigger rectangle on the bottom and then a slightly smaller rectangle on top, which is what my actual target looked like. But yeah, overall, I was able to use these translations through Cartesian, and I was able to rotate this by using trigonometry to actually rotate about the z-axis. And yeah, that's pretty much it.